Hello, and welcome back to Learning with Lee. In today's episode, we are going to take a look at arrays. Arrays are very similar to what we have up here with a double for value, except that rather than storing a single double, it can store a set of doubles. I've mentioned briefly in the past storing things as sets as well as also using arrays, but I never really covered what they were or what they're used for. And what you do is you go, I have some array here, and I want it to contain some number of elements. And you end up using these to represent an array. And within those, you write the number of elements that you want it to store. And the best way to think about this is as a P.O. box or mailbox at a mail office or at an apartment complex, in which you basically have, okay, I've got some decent set of mailboxes here. I've got them sorted into columns and then in rows. And within each of these mailboxes, I can store something, a certain amount of mail, which in this case here is a certain amount of bits. So let's just say that for now, in each one of these, I can store a double. So from our previous one, our value was 100, and that had a single mailbox that it referred to. Now, what an array does is that it allows you to go, what if I want this to, instead of storing a single value, I want to reference a whole bunch of mailboxes. So as that I might have, let's say that I'm a company and that I have multiple P.O. boxes that I use for myself, and I want to be able to know what's in a specific mailbox, or I want control over those mailboxes. And this is how you end up doing it, with arrays. So if I want to access it within here, the first one, and if you'll remember I said that in computer science counting starts at 0, our first value we can assign 100. And once we have it in an array, this one here is our first or 0th mailbox. This would be our first, our second, and so on and so forth. And what we can do then is we can just go, okay, if I want to access the first mailbox, let's just copy this down a line and say that in here, I want it to be 1,000. Fairly simple, fairly easy. Now, here's the important thing though. Unless I specify what is within one of these mailboxes, whatever anyone has left in that mailbox is still there. So if a previous program was using this piece of memory, this P.O. box, and ended up storing, let's just say 1, 2, 3 in it, then that mailbox is still going to have that once we tell the computer we want access to it, until we tell it to store something else. And to demonstrate that, let's combine this, which we have just now introduced, with our loops that we discussed in the previous episode. In this case here, we're going to be using a for loop, because for loops are really handy for iterating over arrays. So, similar to last time, we first do our declaration, in which we create some int, in this case here, let's just call it I, because I is a very common thing when all you're doing is iterating over a list. Then we want to make certain that I is never greater than 50, since that's the number of elements that we have in our array. Then and the important thing of why it has to be less than 50 and we don't want less than or equal to 50 is because of the fact that we start at 0. If we started at 1, we'd want to go to less than or equal to 50, but because we start at 0, it needs to be less than 50. Then we want to, at each iteration, move on to the next element in that array. And the way in which we do that is just by adding 1 to I. So we could do something such as I plus equals 1. However, there's even a more compact way that computer programmers have to do a single increase to a value, and it happens to be the increment operator. And the increment operator is represented by 2 plus signs side by side, and this can either go before or after I. And for now, I'm not going to get too much into what exactly that is, but I'm just going to use it before I. It will end up working either way for your for loop, but in other situations that can be a bit more complicated in terms of how you use the increment operator, one or the other one will have different effects and outcomes. So, in this case here, we do this, we increment it, and within here, let's just go, we want to output I followed by, and let's just get rid of all this, add in this so as we have some delineating character so that it's clear as to what's what. And then afterwards we want to do value. And this is what's known as, you'll hear me say value sub I, and that just means to have these with I inside of it. And it's a fairly common shorthand to reference that. Also, because of what you might notice is that this is an array, and this points to memory that happens to have multiple things here, I can't actually make this conversion from here into here. So value cannot become square root, value cannot become delta, because this is trying to say I have memory equal to 50 doubles in it. And this is saying I only have enough memory for one double. And if you'll take a look down here, you'll see that it cannot convert from an array of doubles to a double. And this happens to be, I could do something such as if I wanted to go value sub 0 here, value sub 1 here, and that would actually end up working then. Because each one of those individual mailboxes in there has enough space to store a double, which is the same as this. So we can say, okay, the memory is compatible, I can make that conversion. However, when you're trying to convert from this, it's a simple matter of the typing and the memory issues do not work out. So let's focus though on the major issue here, and that's that this memory that you get is not cleared out for you. If you want to clear it out, you have to forcefully do so. So if I build it, I run it, you'll note how all of these ones down here have these different values. Some of them are really large, some really small, and that's purely based upon whatever was stored there previously. And this is memory that I myself might never have used for any of my previous programs. It could just be system stuff. It could have previously been instructions for this program itself. Because I don't know where in memory which PO boxes I'm going to get. I'm just asking the computer to give me 50 PO boxes. Alternatively, let's suppose I wanted to clean out that section of memory before I use it, so as that I don't have to worry about whatever was left behind by previous programs. All that I need to do is I can just copy my for loop from up here, put it up here, and then as opposed to outputting a line, we can just go with value sub I equals 0. The important thing to note is that since we're starting at 0, we're effectively going to overwrite the stuff we've already assigned here. So just for now, I'm going to demonstrate that this does in fact clean it out, even though it overwrites the 100 and 1000 because we did these assignments before we assigned 0 over them. And that ended up overwriting that value. Now, one other thing that this brings me to here is that what if, let's say, I wanted to change this from 50 values to 75 values? Right now, I'd have to change this here, change this down here, change this down here, and if this were a larger program, possibly change it in a fair number of other places. So, one of the things that I can actually do for this, and one of the common things that you'll see people do, is just go int, and I'll call it num values to represent number of values, just a bit of a shorthand. Fairly easy. Assign that 50, and then use this throughout here. Now, this happens to have another problem with it, and that's that when you create an array, it has to have a constant amount of memory, and it has to know on compilation what that amount of memory is. And there are ways to do that, and we'll get into that in a second, but just to show that this is indeed the case, and this will give you an error, I'm going to build it over here, and you can see here, in which right now, it doesn't know how large this array needs to be. Even though, really to an extent, you could take a guess that there's that. But there's a way of fixing that. The const keyword says that whatever type you have here happens to be unchanging. Whatever value this gets assigned, you are not going to change that. And it also has a couple of other key things. But first, let me just build this and run this to show that it does indeed work. Oh, whoops, save the changes. Build it, run it. Yep. Everything's back to zeros, and I can use it in all of these locations here. Now, the main reason why it has to be constant is that, let's say that I did this, and this is the major concern. If you just use a normal int, this isn't going to give you any problems in terms of having an int num values like this. It might complain if you use it a bit later on, but in general, if I do this, let's put 50 in here, build, that's going to give me this warning saying that I'm using an uninitialized local variable, but it's not going to stop me from building it. So I could technically run this. I'm not going to because I have no idea how large num values actually is. It could be negative, it could be positive, it could be up near 1,000,000, it could be infinity. So that's the major concern with just using an integer here, is that even if I assign this the value 50, if I have some complex program, I could also have, let's say, some other int, v, and it's declared. It might allow for the user to end up deciding what that is, and then I might, later on in my program, go, okay, num values equals v. But I don't necessarily know if v has been initialized or if it's been correctly initialized. So if I try to do this, that's the problem there, is that this num values could have some undefined amount, in which in this case here, because v, it has whatever was previously in that memory location still there, since I've never overwritten that with an assignment operator. And that can lead to problems. So the const keyword just allows you to avoid a whole bunch of those problems, as well as in case I try to do something such as if I have int v and then do, as you might be able to guess, num values equals v, and do this again, this const operator is going to prevent this from ever occurring. It's going to give me an error on build saying, yep, can't assign to a variable that is const. But the nice thing here is that if I want to change this to 75, I only have to make the change in a single spot in my program. I don't have to hunt down everywhere that's using 75 or previously was using 50 to make certain that's doing that correctly. And the concern is that you might have places that are using 50 as a constant that are using it for reasons that are completely unrelated to the size of num values. Or you might have spots that are using it that are related to the size of num values, but it's unclear from its usage as to whether or not it needs to be changed. So doing this just makes all of your code much more readable, much easier to upkeep and to change in the future. And there is one other minor nitpick with this, and that's that right now, I could have a negative size to my array, and that would be a problem. And I believe it should give an error for this, but if it doesn't, yep, as you can see here, negative subscript, and that's why it's called something like value sub I, is that it's a shortened version of subscript. But you can get that error. However, there's a way in which you can just guarantee that that's not going to happen, and that's to use the unsigned keyword. And the unsigned keyword means that rather than going between, say, negative 256 and positive 255, yours goes from 0 up to 511. So you end up with it being only in the positive integer space. So this is just a good preventative measure here. As you can see, I already had added in these unsigns down here in anticipation for this, because a good compiler is going to give you a warning if I do this, build it, and run it. Unfortunately, this is not a really good compiler. It can be modified in terms of how we have our errors set up so that it can give us that error. But in general, you would want to see an error for comparing what would be an unsigned int to a signed int, because then you wind up with weird things such as negative numbers end up being treated as really large, possibly when comparing with an unsigned int. There just is, because you have to either truncate really large numbers in the unsigned int, or you have to wrap those negative numbers around and treat them as though they were unsigned. And either of those is going to result in aberrant behavior that is hard to predict as a programmer. So it's just a good idea that if you're using unsigned ints in one spot, anything that you're comparing it to, anything that you're doing with it, involves other unsigned integers. Finally, there's one additional thing I would like to talk about before we end our discussion on arrays, and that is multidimensional arrays. At present, I've only shown this so as that you can access something by columns or by rows. However, what if I want to, as our earlier example with a post office box or the like, or if I say had an image with different colored pixels and the like, want to access a specific spot in there? Well, I could do it in terms of saying, okay, I know how many columns I effectively have, or I know how many rows I effectively have, so I know when to basically loop over my count to the next one. And continue on from there. Alternatively, I can just go, okay, I'm going to have two independent counts here. One for the columns, one for the rows, and I can say I want the item that happens to be at the second column, first row, or 0, 0. And that is something that you can do with programming. You can go, okay, let me go here and say that I want to have two columns. Then I can do something such as one here, and I could do like 1, 0. And that would end up working, and I'll just move these down below this for loop so we can actually see where they would get output. Then in here, what I can do, and the order of output we'll show in a second is a bit variable depending on how you do this, but rather than doing this, what you really need happens to be to copy this loop here inside of itself. And then what we want to do is we want to do a second unsigned int, in this case here j. And it's important to change both of these here, though what we're going to want to do is do something such as this, and have a second constant, and we'll just go with numCols for now to represent number of columns and set that equal to 2, so as that we can end up using this correctly, similar to how we did the other one, so as that we don't end up trying to do 50 in here and access memory that isn't a part of our array or anything else like that. Likewise, we're going to have to do something down below like this for our output, so as we can actually output this correctly. What we then do in each of these is that in here, I would do value sub, in this case here, I sub j, and set that equal to 0. Then over here, all I do is I go value sub I sub j. Now, it's important to consider a couple of other things, and that's that right now what I'm looking at is that on each of these, the order in which I'm going to do this is I'm going to print items that are on the same row first, then based upon column. If I were to switch basically I and j for these two loops, I would instead print basically column 1, then column 2. So it can actually make a difference on your performance, on your memory usage, and we'll get into that in the future. But for now, we have this. This should work. It's a bit more than we want to. In case I really want to, I could do something such as, let's go cout, and only go on to a new line once I'm done with a particular row. So down here, output the endl, and then in here, just to make it a bit cleaner, toss in a couple of those, so that we can see where the end of one of these lines is. Save it, build it, run it, and then you can see here how we ended up printing it out, so as that we ended up printing out 100 over in the correct column area, and so on and so forth. Whereas if I had done, let's reverse the two of these, this guy here, copy that, move it here, and then what I can do is go build it and run it. Now it's over in this direction. So I would ask that you spend some time playing around with different types of arrays, trying them out with for loops and doing different stuff with them. But with that, I'm going to say, I hope you have a wonderful day. I will see you all next time.